All right, this is number 4 in the practice test. So for part A, you're asked to find AB. What does that actually mean? Well, when two variables are stuck next to each other without a symbol in between, really it's multiplication. So you're asked to find A times B. So let's substitute. A is root 6, and B is the square root of 5. So all I'm doing is plugging in root 6 for A and root 5 for B. So if I have to multiply two roots, I use one root symbol, and what goes on the inside? The product of the radicands, 6 times 5, which is 30. The square root of 30 cannot be simplified because 30 does not have any pairs. For part B, again, you have two variables next to each other. Really, you are multiplying A and C together. So let's substitute. For A, we have the square root of 6, and for C, we have the square root of 11. So if I multiply two roots, I use one root symbol, and what goes on the inside? The product of the radicands, 6 times 11, which is 66. Again, this cannot be simplified because it does not have any pairs. Lastly, they're asking us, is A plus B equal to C? So let's substitute. A is the square root of 6, B is the square root of 5, and is that equal to the square root of 11? So really what they're asking here is, can you just add the inside numbers when you're adding radicals? Well, we've already proven in class that in order to add radicals, we have to have like radicands. The radicands here are 6, the numbers inside, and 5. These are not alike. They have to be identical. We also proved in class using an example with easy numbers like the square root of 4, because we can simplify that, and the square root of 16. We decided if this was equal to the square root of 20, can you just add the insides? Well, if you actually simplify this, the square root of 4 is 2, plus the square root of 16 is 4. Is that equal to the square root of 20? In other words, 2 plus 4, 6. Is that equal to the square root of 20? Definitely not. In order to get a value of 6, we would have the square root of 36. And root 20 goes on forever, like we explained in class. So, part C, the answer is no. You cannot just add the insides of the radicands.